All right, let's continue our look at the angle side triangle condition, correspondence condition, and see if it's enough to make triangles congruent. We found that it is in Euclidean geometry. How about hyperbolic geometry? Let's look at that. So here is a little activity that we can open up. Let's see if we get the same results here. So the basic construction is basically the same. Here we're given an angle here, which is in radians, another angle here, and a side length. Okay, step one, we're going to start with the side length. I'm going to bring it down a little bit to make it smaller here. We can see it. This is the same side length. That is staying the same side length when we move this around. So those circles and those lines are congruent. Those circles are congruent. Because of the way the distance metric works in this model of hyperbolic geometry, it looks smaller here it is smaller as a Euclidean object, but not smaller as a hyperbolic object. We move it down here. So anyway, we can pick anywhere along here for our first line segment. So we're actually going to do it side angle, just like we did with Euclidean in the last video. So make an angle here on this side. So our other vertex has to be somewhere on this ray right here. That's the angle that's the second angle, the angle that's next to the side, right? So that's our angle B here. All right, next. Okay, I had a method 1 and method 2. I have sort of both methods here. Look at what we've got here. We can manipulate this point until what happens? Well, the green ray is fixed so that it's the correct is this angle C, 0.75 radians is this angle. And we see that the gray ray, the way we have it going to A, is not yet the correct angle. So this is combining method 1 and method 2 from our last video. So we want these two things to coincide. We want this ray, which has the correct angle, but not the correct point A, to correspond with this line segment here, which has the correct points, but not the correct angle. So how many times does that happen? Well, not over here, not over here. There's exactly one sweet spot there where it happens. And here's the final triangle that it occurs. Well, there's the other sides. But there is some sweet spot there. We don't actually have it exactly, but it's where this would be exactly 0.75 radians. But there is some spot there where it'll work. Does that make sense? So really, for the same reasons, we can get it. Now, unfortunately, we do not have the indirect method of just figuring out what this angle is down here at A and doing it by angle, side angle, because where we could do that in Euclidean geometry, that required the angle sum theorem, which we do not have here in hyperbolic geometry. But there is some spot where it works. Okay. That's pretty close right there, 0.75 radians. That looks like that's the right one. So you can see the measure of the sides there, hyperbolic measure, and the measure of the angles. I don't have this angle measure, but you can measure using the angle tools up here. Okay, so what do we conclude? Well, we conclude that the angle side condition works exactly the same in hyperbolic geometry as it did in Euclidean geometry. Also, it's exactly the same because, once again, if we have this angle is too big, there's no way, no matter where we place it on here, see, it's not going to go through A. Okay, so if the two angles add up to pi radians or more, that is 180 degrees or more, then once again, no such triangles are possible, zero congruence classes. But if the two angle measures add up to less than pi, then uh, there is exactly one congruence class possible. All such triangles are possible. If you have two triangles, regardless, two triangles actually exist, regardless what the measures are of A, and S, we don't care. As long as the two triangles exist and they have two corresponding pairs of angles congruent and one corresponding pair of sides congruent, um, where the side is opposite one of the given angles, that's enough. In fact, since we already have angle, side, angle, and now we have angle, angle, side, we know that in both Euclidean and hyperbolic triangle geometries, if we have any two angles, pairs of angles that are congruent, and any one side, uh, pair of sides that are congruent, then we get the two triangles are congruent.